Hello everyone. Today will be part 2 on the astronomy and historical overview. So last lesson we learned about the geocentric model. So we talked about that. So geocentric again was when we had Earth at the center and then everything else orbited around the Earth. Today we're going to look at the heliocentric model. So Helio, if we break apart this word, Helio, some of you will know that Helios was the god of the sun god. And so Helio, this would be and then centric, this would be sun-centered model. So if you look at the diagram here, we've got the sun, and then in these big circular orbits around here, we've got the other celestial bodies. Now, just following it along in your notes here, we're going to actually, this is when I would want you to watch a video on Copernicus. So Copernicus is our next scientist that we're going to take a look at. So just pause this video and try and watch the one on Copernicus now. So his model, the heliocentric model, was proposed by Copernicus in the early 1500s. So this is what you need to copy down in your notes there. He proposed the sun was fixed and that the earth orbited the sun. He also proposed that the earth was rotating and that the stars moving across the sky were merely an illusion created by the rotating earth. So he thought the stars were fixed. I'm just going to write this down. So stars were fixed, which means they didn't move. The earth was just rotating. He withheld publishing his theories until he was on his deathbed because he was likely scared of what the church would say. Religion and science were often at odds during these periods. So he finally published what he said on his deathbed in 1543. Now, Kepler is next. So now again, I'm going to get you to watch the quick little video on Kepler. So you can do that. Kepler basically introduced more accuracy. So he made the predictions of the model more accurate by suggesting that the orbits of the planets were ellipses, not circles. So ellipses are these sort of long oval shapes like this, right? So instead of having circular orbits, it was now elliptical orbits, which was correct. Now, before we talk about Galileo, we're going to just, in you've got two squares at the bottom of your page there, so you have to write the two models. So the Copernican model, again, you're going to have the sun in the center, and then you're just going to draw circular orbits around. So these are, oops, I think I had one too many dots there, but you get the picture. And then the other model, this is the Kepler model. This is when we would introduce our elliptical orbits. So we're going to be drawing them like this. And so we're showing them the planets orbiting around the sun in elliptical pattern. So ellipses, not circles. Okay. Now, hold on. I think I'm missing a point. Oh, well, it doesn't matter. Okay, now Galileo. So now we're going to watch the video on Galileo. For me, he's the most interesting one. He was a bit of a rebel. So watch the video and write down 2 interesting facts from the video. So Galileo proved, Galileo saw, Galileo revealed. That's a quote from that video. It took the invention of the telescope to really drive astronomy research further. So Galileo is credited as being one of the earlier discoverers of the telescope. I think there's a bit of controversy over that. Some people credit it to other scientists. But Galileo was responsible for the invention of it in a lot of people's views, and he used the telescope to prove the heliocentric model. So we then knew that the heliocentric model was in fact true. Now, Galileo was a devout Catholic, and he published a document called the Starry Messenger in 1610. Now, what was interesting, though, is there was a lot of controversy with him in the Catholic Church. So one of the quotes is, "The Bible tells us how to get to heaven, not how the heavens go." So if Galileo had been more that quote is credited to Galileo. So basically, if he had been more careful with his words, he may not have been in so much trouble, as the church originally had no problem with his findings. The problem arose when it was seen that he was personally interpreting scripture without the aid of the church, and so he got into a lot of trouble with the church because of his language choices, and was banished to house arrest for a lot of years. It took the church until 1832 to remove Galileo's work from its list of books which Catholics were forbidden to read at the risk of dire punishment of their immortal souls. So that's actually not too long ago, really, a couple hundred years ago. And Pope John Paul II expressed regret in 1992 about how the Galileo affair was handled. So just a sort of interesting piece of how the science fits into the history there. So the modern heliocentric model of the solar system is still what we use today. So this is the commonly accepted model, of course, where we've got the sun in the middle, and then we've got the elliptical orbits, right? Good. And I like this one. It's kind of an old song now. You guys may not remember it. I throw my telescope in the... Oh, I screwed it up. I throw my telescope in the air sometimes, singing, Ayo, I'm Galileo. Do you guys remember that song? I hope so. Anyways. Okay, that's it for the notes there. Now, the assignment for this, you're going to finish the worksheet on celestial model questions. They're all very straightforward, so hopefully that won't take you that long. And then in the textbook, I'd like you to answer the questions 1 to 5. On page 310. So take a look at those. Okay.